Here we are again, an update on the MegaIC Tester. Software is now up to version 5. As you can see on the front panel here, as well as support for 14 to 24 pin chips, I'm now supporting 8-pin chips as well. I've only got one of those, and it's this 40107. So we'll pop that into the ZIF socket. Do an identify. I've lost the all pin test identify mode because I thought it was a bit naff. Do a test on a 40107. There it is. Passes the test. And now for the majority of chips that are actually in the database, there are logic symbols defined, so it's showing us we've got 2 NAND gates here. They're both good, and we can look at the pinout, and here's our very sparse chip. We can step through the test cases as normal. We can move into manual mode, or in this case it's gone into immediate mode because it's looked at this chip, found there are no clocks or strobes or anything like that on it, and therefore the first thing that you're going to want to do is manipulate it manually. So rather than moving into manual mode where you have to set the inputs and then hit the test button, it's moved straight into immediate mode, so we can immediately start testing the chip in whichever way we want. Okay, so something else that was on there, just to show you, 40107, a couple of things. Okay, so we've now got a key in the center of the chip here, which shows us what the individual colors are in terms of which element they relate to, and we can actually poke one of those and it will show you this diagram where it's showing us the actual individual elements on the chip. And if I actually poke the right area of the chip, I can go and look at element 2, and it just shows us element 2. Now this view will include the pins that are associated with this element, and we can then manipulate those manually rather than doing it on the actual physical layout of the chip. So that's a bit more sensible. And the other thing you might have noticed is we've also got a logic button down here, and that takes us to that multi-element view. And I'm also working on a timing diagram facility whereby it will actually show you a timing diagram of the test steps, so you can actually look at what's going on during the tests, so you can get a better understanding of how the chip works and what the test does to exercise it. But that's early days yet. Right, so if I pop that out, pop a 7451 in. 7451 has got multiple element types on it, so if we go and do an identify 14 pin chip, okay, now you can now pick from that list of chips as soon as the chip you're interested in comes up. So it's testing that. So it's a 2 wide 2 input and a 2 wide 3 input and NOR gate. So on the element diagram here we've got 1, 2, 3, 4 AND gates and then 2 NOR gates. And if we go and look at the pinout, we'll find that the AND gates have all got only inputs and the OR gates have only got outputs. Right, so we can manipulate this and check that it all works, but as you know, the test cases have all been run and it's behaved itself. So that's showing you multiple different element types on the chip. Right, now if we put this in, what's this one? Okay, so this, no, we'll not put that one in. What's this one? Okay, so this is a 4020. Right, do an identify. See if I can count properly this time, 16 pins. So watch how long it takes to find it. It took about a second to find that 14-bit counter. So we've got our new LED here, which is showing us that it's actually testing something. Okay, Now you might have noted that that test there took a lot longer than the 1 second or so that it took to identify the chip. That's because I've divided test cases now up into 3 different areas. A short set that are used to examine the chip to see if it matches a particular chip. So it did a few tests and found that this behaved like a 4020, so it showed it as a potential candidate. Then when you go into this test mode, it runs a wider set of tests to see that it really is one of those and that it's behaving properly. But it doesn't fully exercise the chip because a 14-bit counter takes quite a few cycles to validate, and therefore the new facility that I've allowed to cause any test case to be run multiple times and the outputs only to be tested at the end has been used to implement these test cases for this chip. So if we go into the pinout, we've got 14 test cases here. Now only about 5 of those are run to identify the chip. Then maybe another 5 are used to initially test it when we moved into this mode, and then the final 4 or 5 are used and are only available in this manual test mode. So if we go at the moment, we've got all the different divide options which show what the count's doing, and if we do a test, it's going to say, right, so we're going to reset, check all outputs low, then we're going to clear the reset but not do a clock, all outputs should still stay low, which they have. So then I'm going to do 2 counts and check that the divide by 2 goes low, which it has. So then I'm going to do 2 more counts and check that it goes low and then high, which it did. Okay, it's now doing 6 counts. Now you might have noted there that it was actually showing us the outputs changing as it ran those. That's because it's utilising the new multiple test facility, which we can see a bit more. So there you go, it's done 8 more counts, /32's gone high. Now when we move on, up here we've got a progress bar, so it's running in slow mode at the moment, and in slow mode it shows us all of the outputs after every single step of the test case. So if we actually touch there, we can flip to fast mode. So the next one's going to do 64 steps and it's running quickly. The next one's going to do 128. There you go, so the /512 line's gone low. The next test will run, we'll flip back to slow mode, and there you can see the /2 is going up and down, /16 goes, so we've got 32, 64, 128, 16 will go up, and 256 will go up. There you go. Right, so this is showing the multiple test cases and the ability to move between fast and slow modes to do the testing. Now the final test, which actually exercises the full count capability of the chip, takes, I don't know, 2 or 3 minutes, but at least it does do a full and thorough test of the chip. Now if I go back into test case mode and step through things, but if I move into manual mode, you know, we've got the ability to change the inputs and then apply them with the test button, and then it will show us what the outputs are. So there's the /2 going up and down, there's the /16 going up and down, but we've also got a Mult button here, and in manual mode I'm going to make it so that you can actually do multiple tests just like I showed you in the automated tests, but I haven't fully implemented that yet. Okay, so just to talk about the changes to the hardware, as I said, we've got an LED down here which shows when we're doing a test, and on the display here we've got this little connector here which has got a red pin on it and a blue pin on it. The red pin can be used to cause the tester to do the next step if we're in test case mode, or it can be used to apply all the current inputs and controls if we're in manual mode. And the stepping output can be used to trigger, say, a logic analyzer or something like that, and that's what I've been using it for, in order to see when a step is actually being executed for a set of tests. Down here we've also got ground pins and 5-volt pins which are coming straight off the Arduino Mega, and I use these which I slot into the ZIF socket alongside the chip, and then that means I can use my logic analyzer to see what's actually going on while the tester is testing the chips, and I can validate test cases. And I can then use the ground and 5-volt pins and a breadboard down here, and these inputs and outputs and I can then manipulate things on the breadboard utilizing the chip that's in the socket. Okay, the next chip I'll stick in is, what's this? No, I'll stick that one in. I'll stick this one in. So this is a 24-pin chip, the 74867. So this fully exercises all the capabilities of the ZIF socket. Okay, so there's an example of the symbol for a tester, sorry, for a counter. So it's an up-down counter, 8 bits. It's got a clock input, it's got a reset, and it's got outputs. And if we go and look at the pinout, right, so this is fully populated. This is as many pins as we can get on the on a chip in the ZIF socket. So you can still see it's perfectly readable and it's perfectly usable. You know, manipulate the inputs and outputs, no problem. You know, let's put it into load mode, right, and then because we're in, let's put it into immediate mode, and we can then manipulate the inputs and get them immediately applied, and see what's going on. So if we do, if we go back in test mode on this one, it steps through the tests, and just like on the 4020 chip, it's going to do count 253. Okay. So it's now going to, where are we? We'll step through a few more of these when we get along to, because this is an 8-bit counter, to fully exercise it and check that it's working, you would need to count all the way down 255 times and then count all the way up 255 times. So here we've got this, and it's actually running through doing that count. And it's doing it in slow mode. Come on. So we flip to fast mode and back to slow mode. So there you go. That's another chip showing the counting capability and the multiple steps. In terms of the database, if we want to re-index, see where I've got to with the database. Just thinking about it. So we've got 204 chips in the database, 203 of those have got pinouts, 178 have got symbols, and I've personally checked 115. And if we go in and actually say, so we'll pop the 74867 back in. Now that star that I've put on the end of the description there is the way that I denote the fact that I've personally tested that chip, and that's how the tester knows how many I've tested and how many haven't been tested. Okay, just to show you what else I've done, 74 to 43 I think this is. Tested, 14 pins, no, 74 to 43. We're not the right one? Yes, I have. Okay, so this is a non-inverting bus transceiver. This is the symbol that we use. So it's 3S for tri-state, and it's a transceiver because we've got buffers going in both directions. If we look at the pinout, then this is just to show you what I've done with bi-directional pin support. So these pins on this side and these pins on this side are both bi-directional, and I can actually manipulate the pin from an input back to an output, input, output. When it's an input I can manipulate it, when it's an output I can't. So that's how I've done bi-directional pins. And just to show you the diagram for something like the symbol for something like a flip-flop, I've put a 74 in here, I think. So there you go, dual D type flip-flop. So that's the D, the Q and the not Q, and the input. In terms of what chips the logic tester covered, here's the first set of logic chips, the second, quite a wide range. Then we've got more logic chips, then we've got counters, then we've got a load of flip-flops and shift registers and things like that. Then we've got multiplexers. Oh, sorry, that's where the shift registers are. Then we've got some transceivers and various ones I haven't classified yet. Right, so that's where I'm at. I'll be back with another update soon. Hope you enjoyed it. Thank you. Bye.